Hello, this is Ms. Schultz filming a pre-calculus lesson where the objective is to solve exponentials using log and natural log, log and log and ln. And so there'll be problems that look like this, where you have a variable in the exponent and you need to solve for that variable that's in the exponent. So that's what an exponential is. It's an equation where the variable is in the exponent. Okay, not just has an exponent, but the variable is in the exponent. All right, so we're gonna use this as reference of how we solve this. There's a couple different methods, but we're gonna use this conversion formula. All right, so we have example 1, 3 to the x minus 16 equals 21. So how we're gonna solve this is we add 16 to both sides, like you might think. So basically, you're isolating the exponential part, all right? So now the exponential part is isolated. Great, we have 3 to the x equals 37. So I'm going to solve this by rewriting this as a logarithm. All right, so here, so this is an exponential. So I have 3 to the x equals 37. In other words, it's like 37 equals 3 to the x. All right, so I have the exponent here is what it equals. So that's x, sweet. So x equals, so I'm taking this and I'm basically rewriting it according to this that it's equivalent to. So x, which is the exponent, which is x, equals, and then I write log, and then the base is this base here. So what's the base in this? The base is 3, so I put a subscript of 3. And then the argument is what the exponential equals, 37. Sweet. So now this is really wonderful because I have the variable isolated. And so I just need to figure out what log base 3 of 37 is. I'm going to use my calculator, but we could estimate it. We know that 3 to the third equals 27, and 3 to the fourth equals 81. So log base 3 of 37 should probably be 3.2, 3.1. All right, but in order to enter this, so that's our estimation, but in order to enter this in my calculator, if you flip over on your notes, here are the directions. So I'm gonna actually do log base 3 of 37. Okay, so on your TI calculator, you want to press the math button. So here's the math button. It's the third one down on the left. Okay, and you see something that looks like this, all right? So we see that. Now, from here, just keep scrolling down until you reach the log base whatever option. I can scroll up, but I'll just scroll down to show log base there, okay? So that's answer choice A. And then I press enter. All right, and then you see the template below. So if I want to enter log base 3 of 37, so base 3, I arrow over 37, I just press enter, and that's it. It was a little higher than I thought. 3.2867, okay. So I did not specify what I want you to round to. We'll do the 100th for this one. I will not take off points if you round to if I don't specify how to round to, it doesn't matter, okay? Just choose something that you want. So 2, 9, that would round to. The 6 would bump the 8, and the 100th place up to a 9. And that's my answer. So to recap, I isolated the exponential, step 1. I rewrote the exponential as a logarithm according to this conversion formula up here, and then I used my calculator. I could have also done what's called the change of base formula and done log of 37 over log of 3. That's a formula, so log of 37 divided by log of 3 gets you the same thing, but we'll just use the math button from now on. All right, let's do this one. So I want to isolate, so I have 2 e to the x equals 54. So I want to isolate the exponential of this part. So I want to get rid of the 2. So I'm going to divide by 2 on both sides. So I have e to the x equals 27. 27, I think. Hold on. 27. Why did I? u to the x equals 27. Wow, that was embarrassing. Okay, so now anytime there's a base of e, let's write this. If the base is e, you rewrite it as a natural log. Rewrite as ln, because ln is base e, ln of dot, 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 okay? The ln, it doesn't show the base here, but it's an invisible base e. So if you have a base e of your exponential, you rewrite it as ln, okay? So to rewrite it, my exponent here is what I equal. So I have x equals, and then instead of log, I'm gonna write ln. I could write base e, but I don't have to. The ln, it is already base e, okay, of y. My argument is what my exponential equals. So in this case, it's 27. I could put parentheses or not. Okay, so this is the conversion. E to the x equals 27 is the same as finding the natural log of 27. In this, there is an ln button, which is next to the 4 key right here. So I just type ln of 27, which is 3.2958. So I'm going to round that to the nearest hundredth and do 3.3. I could do 3.30, sure. And that is my answer. So I just solved two different exponentials, one with a base that's an integer and one that's a base e. And e, recall, e is about 2.718, 2818, etc. Just so that you know. Okay, let's move on to example 3. All right, so I have this, looks a little more complicated, right? So I'm gonna isolate this exponential part. That's what I'm isolating. Isolating. That's what I'm isolating, that part. So think about what you do first. All right, you wanna subtract 10.7 from both sides. Subtract 10.7 from both sides. Please do not use your calculator for this. Use your brain. So I have 5e to the 3x left. 5e to the x plus 3, excuse me. 5e to the x plus 3 left equals, the difference of these two numbers is 500. Now, to isolate this, I'm going to divide both sides by 5. So I have e to the x plus 3 equals 100. So now I rewrite this as a logarithm equation, all right? I rewrite this as a log. So how I'm going to do this, I know it's base e, so think about what kind of logarithm I'm going to rewrite it as. Yeah, I'm going to rewrite it as ln. Okay, so I have my exponent is what you equal. X plus 3 equals, because here the exponent is what you equal, is like on the one, is isolated on one side of the equal sign. So my exponent here, notice it's not just x, this is a different problem. My exponent is x plus 3 equals, and then ln, natural log of 100, okay? So my variable isn't isolated yet. I'm gonna use my calculator in a second. I could use it now, but I'm gonna use it in a sec. I'm gonna subtract 3 from both sides. X equals, you can't combine these, it's just ln of 100 minus 3. I like using the parentheses to show that the 100 is the argument of natural log, and then minus 3 is not part of it. All right, so let's use our calculator. Again, the ln button is next to the 4 key on the left of it. So ln 100 minus 3. 1.61. I'll keep with rounding to the hundredths. So x equals 1.61. I'll do them both. So this is technically the exact answer, and this is an approximation. It's a very, very accurate approximation because it's nearest hundredths place, but this is the exact answer, and this is an approximation, okay? All right, let's do our last example, example 4. So let's take a look. This is a very purposeful example because this is related to a formula to compute interest that we're going to learn later. So this is a really useful formula to tell that if you save money and you have a fixed interest rate, then you can predict in one amount of time, you'll have a certain amount of money. Okay, so I have 10,000 equals 6,000, parentheses 1 plus 0.05 over 12 to the 12t. So I'm going to start by isolating my exponential, okay? All of this is what I can isolate. So think about what you're going to do first. You divide by 6,000 on both sides. Okay? So I get 10,000 divided by 6,000, which is 5/3. You could simplify it or not, but I'm going to simplify it. 5/3 equals 1 plus 0.05 over 12 to the 12t. Okay? At this point, see how there's all of this, there's no variables in here. So I'm actually gonna compute this using my calculator at this point. You could do it later, but I recommend doing it at this point. So I'm gonna enter 1 plus 0.05 over 12 into my calculator. Yep. And I get this. I'm gonna round to lots of decimal places, okay? I'm just gonna like decide on the fly how many, but lots of decimal places. Like 6 decimal places. Because exponentials with their really fast growth, it's really gonna matter, those extra decimal places. 1.004167 to the 12t, okay? Now, okay, so I have this. So this is just got complex numbers, but the same idea as one we've solved before. So I have an exponent in the variable. I have a variable in the exponent. That is how I know to solve it, I need to convert to logarithm. So I have a variable. So how do I do it? My exponent is what I set the equation equal to. Equals log, and then I take my base, and then what it's equal to becomes my argument of log. So I'm going to start with my exponent equals. I'm going to start with my exponent equals 12t equals. Okay, so I took care of that. So exponent equals, then I do log base, whatever my base is, of what's the argument becomes what's on the other side of equals to. So my base is, so I do log base 1.004167 of 5/3. That's how I convert this to a logarithm in order to solve. So t isn't quite isolated. For this one, I'm just going to divide by t I'll divide by t. But you'll see, I'll divide by t now, but you'll see how I enter it. All right, you ready to do this? So to enter this in, here are your directions up here. All right, so I'm going to press the math button, which is third from the top left, and then I scroll down, or rather up is also, so I press the math, and then I'm here. You can scroll up and you get to it almost right away. And then I just type this in, 1.004167. I arrow over 5/3, that's all in the parentheses, and I can press enter and then divide by 12, or I can just divide by 12 now. I'm going to divide by 12 now. 10.24 is my answer. 10.24. So this doesn't have any meaning for us right now, but this will have meaning. This would be 10 1/4-ish years, T for time, but this doesn't have any meaning now. All right, and that is how you solve this complex thing. So to review, I always isolate my base and exponent, okay? After I isolate my base and exponent, then I rewrite, well, I like simplified my base, kind of, I rewrote it as a decimal. Then I rewrite as a log, okay? And then I solve for t and enter it into my calculator. And that is how you solve exponentials. That's how you solve exponential equations using log and natural log. All right, thanks, bye.